Hi, my name is Anna.
My name is Josh.
And my name is Michelle. We are Group 8 and this is our Robot Jam. We are in collaboration with Group 2.
Hello, my name is Ray.
My name is Ryan.
And my name is Yusuf. We're Group 2. This is our robot, Lil Lego. Our project is designed to play a game of tag in collaboration with Group 8. Our final project introduces ideas from chapters 5 through 7 and takes turn with the Robot Jam to interact between states of not it and it to play this game. Now that you know about our project, let's introduce you to our robots. This is Lil Lego.
And this is Jam.
We started building the robot with 2 motors here attached to the hub. There are 2 wheels attached to the motors, one on each side, and the ball right here keeps the robot level, causing the robot not to drag in the front. The motors and the wheels allow the robot to move.
This is the color sensor, which is coded to detect magenta, and this is the distance sensor, which measures the distance between the robot and anything else. The rest of the robot is intentionally decorated all around with cyan pieces, so that Group 8's robots can detect it.
Jam is also built in the same way with 2 motors and 2 wheels, a color sensor, and a distance sensor. The color sensor is coded to detect cyan, and the robot is decorated all around with magenta pieces so that Group 2's color sensor can detect it.
Our robot is covered in magenta pieces, while Group 2's robot is covered in cyan pieces. Our robot will start off as being it, meaning it will explore the environment and find the color cyan, and once cyan is detected, our robot will go towards it in order to tag it.
Once our robot tags the cyan robot, the robots will now switch states and our robot will now be not it and start running away.
The goals of these robots are to be in the not it state for as long as it can, and if they are in the it state, it will be incentivized to be in the not it state.
Now, let's take a look at how our 2 robots interact in a live demo space. Our robots include 5 unique functions that allow them to operate in their environment. The first of those is the Explore method. The Explore method exists at the lowest level of our subsummation architecture and is the default state when all other conditions are met. What this means is when the sensors are not detecting anything and there's nothing hazardous in the way of the robot will default to this state. Exploration is defined by random movements that include turns and movements in the forward direction that allow it to interact randomly with its environment. The second, one of the most important functions that our robot executes, is the Avoid function. Avoidance is a process by which, when either robot detects an obstacle with its distance sensor, it's able to make small turning adjustments to move out of the way of the obstacle. Once it detects that it's clear of the obstacle, it's able to resume with exploration. Depending on which state the robot's in, it may engage in one of the 2 following actions. The first is Chase. Chasing is a function that's executed when the tagger detects its opponent. Chasing is characterized and specified by the detection on both the distance sensor and the color sensor, indicating that the obstacle in front of it is not just any obstacle, but rather is something it should be pursuing. Chasing involves a bull-like chase forward until it has either bumped into the object or the object is no longer in view. Similarly, if the robot is in the not it state, it may execute the Run function. The Run function allows the robot to, when detecting the opposite robot on its distance and color sensors, turn away and run in the opposite direction. Cyan detects violet on its color sensor and distance sensor, and then uses this as an opportunity to run away before it gets tagged. Cyan will turn briefly and then move in a perfectly straight line, following the arrow shown on screen, to avoid being tagged. In the following recording, we see our 2 robots start off a game of tag. Immediately, Violet bumps into Cyan. Since Violet is in the it state and Cyan is in the not it state, the Cyan console, as shown below, receives the tag and registers that it is now it, printing the statement, "I'm it," with a sad face. Afterward, Cyan will pause for a moment, as seen here, to allow Magenta time to run off in the opposite direction. After 5 seconds have elapsed, Cyan will resume motion. The last and most important function is the tag function. When two robots bump into each other, meaning that all other functions have failed, a tag ensues. What this means is that the robot that is it becomes not it, and the robot that's not it becomes it. In accordance with fair play, when a robot has been tagged and becomes it will wait for 5 seconds to allow the other robot to go off, run away, and explore before resuming activity.